The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Using the half reaction method, balance the following redox reaction in acidic solution. Here we have dichromate and chlorine ions reacting to give us chromium and chlorine, right? Now, let's go back to our slide and see what we need to do first. Here, we're being asked to identify and write out unbalanced half reactions. Thus, if we come back here, let's first identify the oxidation and reduction half reactions. We see that the charge on chromium here is going to be +6. The charge on chlorine here is negative. The oxidation number is going to be -1. The oxidation number for chromium here is +3, and the oxidation number on chlorine here is 0. Now, one of our reactions here is going to be oxidation and one is going to be reduction. Because we see that our chromium, the oxidation number on it is going from +6 to +3, thus this is our reduction half reaction here, right? Great. Now again, if you're uncomfortable with finding oxidation numbers, this would be a good. We actually spent a significant amount of time at the beginning of this lecture series finding oxidation numbers. Thus, pause the video now, go back and take a look. Now, secondly, that tells us then that our chlorine here, well, that's going to be oxidized. Great. Now that we know our oxidation and our reduction half reactions, let's just go ahead and write them out over here. And we'll begin here with our reduction reaction, beginning with our dichromate here. And make sure that you get the appropriate charges on your compounds, otherwise it could prove troublesome as you're working through the problem. Great, and now we'll just write out the unbalanced half reaction here for oxidation. That's just going to be with our chlorine atom here, great, and our CO2 aqueous as such. Okay, great. Now that we've written our half reactions, let's go take a look at what we need to do next. Next, we're being told to balance the half reactions, leaving hydrogen and oxygen atoms for last. Thus, if we see here, we see that we have 2 chromium here on the right, and we only have 1 on the product side of our reduction half reaction. Thus, we're going to need to place a 2 here to balance the chromium. And for our oxidation reaction, we also need to balance our chlorine as well, right? Thus, we're going to need to place a 2 on the reactant side here as well. Great, now that we've done that, let's take a look at what we need to do next. Next, we're being asked to add H2O to the side with less oxygen, then add H plus to the side with less hydrogen, right? Let's go ahead and do that now. Looking at the reduction reaction first, we see that we have 7 oxygens here, thus we're going to need to add 7 water molecules here to the product side. And in doing so, we see that we're going to also have to balance out these hydrogens here, right? And to do that, just as our slide had directed us to do, we can just add 14H plus to the side with less hydrogen, right? Now, how about our oxidation half reaction? Since we don't have any oxygens and hydrogens here, we can leave that one as is. Great, let's go back here and see what we're being asked to do next. Now, what we need to do is we need to add electrons to balance the charge on both half reactions, right? Great. Now, if we take a look here, we see that the charge on the reactant side is going to be +12, right? On the product side here, we see it's going to be +6. Thus, we're going to need to add 6 electrons to the reactant side, and that way the charge on both sides is going to be +6. Let's go ahead and do that. Here it's 6 electrons as such. How about for our oxidation reaction? If the charge over here that is on the reactant side is going to be -2, and it's 0 on the product side, how many electrons are we going to need to add to the product side here? That's right, 2 electrons as such. Great. Now if we go back to our slide, what are we doing? We added electrons to balance the half reactions. 5, balance electrons in both half reactions by the appropriate coefficient. Great, let's go ahead and do that next. Now, we see here that we have 6 electrons in the reduction reaction and we have 2 electrons in our oxidation reaction here, right? Thus, in order to do this, we're going to have to place a coefficient of 3 on our oxidation half reaction, and now our electrons are balanced. We have 6 electrons here and we have 6 electrons here. Now we can skip to our last step here, and it says add both half reactions and cancel like terms. Thus, let's go ahead and take that route now. When we go ahead and we add our like terms and we cancel, we add our like and we cancel like terms. We cancel like terms and we add, here we have our 6 electrons canceling, we also have our 6 electrons canceling here as well. Now we can go ahead and write out the rest of this reaction here. So we had 14 H plus. We also had our dichromate ion here that we need to account for, Cr2O7 negative. Great. And I'm just going to go ahead and highlight it. That way we know that we've accounted for it and we don't miss anything. Okay, great. Thus we've got those 2 out of the way. Now we need to also account for our chlorine here, and that's going to be 6Cl negative aqueous. We've accounted for our chlorine. Now we can take a look at our products. Excuse me. Here we have 2Cr3 plus, right, plus 7H2O. We also need to account for the 3Cl2 aqueous as such. We've accounted for the chromium, we've accounted for the water, right? We've accounted for the chlorine here as well. Great, thus we are finished. Now, it's never bad practice to always, once you're done, is to go back and check to make sure your atoms and your charge is balanced. Here, 14 minus 2 is plus 12, and then minus 6 is going to be plus 6, and here it's plus 6. Charges, atoms are balanced, we're good. Great, let's now move to our next slide.